Good afternoon, everyone. I, Ms. Hetvi Bhanushali, along with my companions Ms. Isha Shah and Mr. Soham Doshi, is here today to present our project, a stationary approach for Kathak posture recognition using MediaPipe. These are the few points that we are going to discuss today. So, have you ever thought of learning Kathak as your passion or hobby but you couldn't because of your busy schedule? Many people residing in rural populations and even the urban dwellers face the challenges in learning this classical dance form due to their demanding schedules. Therefore, we have come up with the system designed to preserve this classical dance form by leveraging media pipe and advanced machine learning models. The proposed system starts with an instructional video on mudras and postures, followed by real time movement analysis and feedback. Through a comprehensive literature review, various studies in gesture recognition, motion sensing, and facial recognition were examined. Gesture recognition because we want to detect an object in our model, motion sensing because we aim to do it in real time, and facial recognition because we do not want to miss the intricacies and even the minute details of the user's performance. We performed analysis on this literature survey by categorizing it into three parameters: dynamic scenarios, multiple objects, and visual angle. This table shows which paper considers which parameters and which they don't. After a thorough analysis on this literature survey, it resulted in revealing some research gaps such as limited data sets. Limited data set because there was this research paper where Bharatnatyam dancer's performance was posture was detected, but they considered only 500 to 600 images to train their model, which is not enough to train a posture recognition model. Next is distance constraints between the camera and the performer, followed by lighting conditions. So there were some research papers which could not accurately detect the object in low lighting conditions. And the last is multiple performers, that is, some research paper could not even detect the object when multiple performers were performing in the same environment.
Now, moving towards the problem definition. Our main objective was to create a platform where users or Kathak dancers could actually test if their gestures were correct or not. For doing so, we have used computer vision, some machine learning algorithms. We have done real time detection as well as some analysis over this. This is the system architecture. So the very first thing is the input frames. So these are the data set that we have collected either through images or the videos that we have converted into some frames. Each image contains a hand gesture. So the second is to detect the gestures in these images. So hand detection is performed using MediaPipe, a popular open source framework developed by Google. MediaPipe provides pre-trained models for hand detection, which efficiently localizes and identifies hand regions within the input frames. So once the hand has been detected, we need to analyze which landmarks are visible in these images. So the third is landmark extraction. We wanted to do analysis over three main gestures, which is pataka, ardha pataka, and tripataka, for which we have realized that seven angles were enough of a sufficient to detect these. So we formed CSVs of these angles for the three gestures, which was at the pataka, and shikhara. We combined them into one, and then we did some data pre-processing, which includes removing the missing values, any inconsistencies, any outliers. We did normalization if required, and then once we had the data set, we split them into training and testing with a 80 to 20 ratio approximately. We have used three machine learning algorithms, which were gradient boosting, random forest, and logistic regression. So let's see their analysis. This clearly shows that random forest worked best, gave the best accuracy. And then moving towards the last part that we have implemented is the KS statistics. This is to back up our ML model. So let's see why we did so. One of the primary goals in machine learning is to generalize well on the unseen data. When training a model, you want it to learn the patterns from the training data that can be applied efficiently on the unseen data. So, K statistics helps us to evaluate how well a model generalizes. Another point is overfitting. So, overfitting occurs when a model learns to capture noise or random fluctuations in the training data. This can lead to poor performance on the new data. So, KS statistics also helps us to detect the overfitting. Since our model predicted that output distribution for both are similar, which is the training and testing sets, so it suggests that our model could generalize well on the unseen data. So hence our model is robust, it's reliable, and it indicates that the model's performance is not heavily influenced by any particular specific characteristics. Next is result analysis. So the image on the left is the correct pataka detection, while the adjacent one, the model could not detect because my fingers were separated apart. The same way it can detect Ardha Pataka and Shakhar. Some of the gaps were that the models could not detect accurately the gestures if it was captured from a distance, but in our model it can do so. Sometimes the Kathak performers apply a red ink or alta over their hand before performances. So we just wanted to try with some black ink if it can still detect the postures correctly, which it can. The other gap for multiple performers in one frame, our Kathak model can also detect multiple performers doing different gestures in one frame.
In summary, our interactive Kathak learning system represents a significant step towards preserving and advancing this classical dance form. However, challenges remain in accommodating intricate gestures and diverse dance forms. Overcoming these obstacles will require continued advancements in computer vision. Moving forward, we aim to expand the system's capabilities to encompass full body movement recognition, enhancing the learning experience further. Thank you so much.